Hi, my name is Noah Challens.
I'm Andrew Bobo.
I'm Zach Hansen.
And together we are the Countertop Calendar Senior Design Team. This project was completed to showcase our industrial engineering skills in conjunction with the MSOE Create Institute's MSOE Mindset to showcase an entrepreneurial-minded learning opportunity.
Looking at these stats here, you can see that Americans are thinking about weight loss and dieting on a major level. Furthermore, this has led to a weight loss products market being worth multi-billions of dollars. From these different stats, the team interpreted that despite having the nutrition label provided on some products and foods, that people are still finding it difficult to count their calories. And even so, that there's no way for people to do this at home.
Over the course of this project, our team intends to develop a functional proof of concept prototype capable of burning a food sample and outputting the amount of calories. Along with that, we'll be creating a business plan showing financial metrics such as return on investment, profitability, and break-even point.
Listed here are the different high-level milestones that the team decided would determine the success of our project. From these, the team touched on multiple different IE-related tools and methodologies, industrial engineering tools and methodologies to express what we've learned, which are explored later in this presentation.
The first deliverable our team began working on was a demand data analysis, looking at the market target demographics, as well as conducting a SWOT analysis. Here you can see the market target demographics for interest in calorie counting. There's a high interest in young adults, and there's the probability density on the right and the population millions on the left. We also use this to create a stochastic forecast demand.
The SWOT analysis stands for the strengths, weaknesses, opportunities, and threats that the team has decided for these 4 different areas to look into critically in order to make sure that we are ready for anything that came our way. Once again, this is in the demand data analysis.
The team has also been conducting an ongoing value engineering analysis. Value engineering is done to drive industrial engineering concepts into the product development design process. How this is done is by maximizing the amount of function per product, but also minimizing the amount of cost. This is done by identifying primary functions, which is a verb and a measurable noun that are specific to the customer, but also by identifying the secondary functions of the product, which are things that support the primary functions. This is our value engineering FAST diagram. A FAST diagram is just a visual representation that shows the high-level process and layout of these functions.
The methodology used by the team was design thinking in order to frame around the industrial design of this team's calorimeter. The first phase was the inspiration phase, where the team looked at different products on the market to look at their different various features that were closely related to what we were trying to accomplish here. As well as the voice of the customer was obtained by a survey in order to create this mind map, and also the critical to quality tree that you can see here. This critical to quality tree listed out different metrics that were important to the customer. The next phase, we decided to ideate on different brainstorming techniques in order to develop the different sketches, as you can see here, that were used as the different alternatives that were weighed in the decision analysis. For our weighted decision matrix, we were able to quantitatively decide on which one was our best. With our implementation phase, we worked on two different prototypes. First being the proof of concept prototypes, as seen here, which were done in 3 different iterations. And with our last iteration, we are still finding issues where we are consuming the nickel chromium wire during the reaction. However, we are able to move on to our production rendering. As to see here, this is what the team envisions the product will look like when it's actually on the shelves being sold in stores. So we can just take a look at this.
Wow.
Our team also did an air propagation calculation for the thermodynamic equation required to calculate the amount of calories in a food sample, trying to find the variability in the specific enthalpy.
Our team also completed a design failure mode effects analysis, or DFEMA. This is done to identify specific failure modes and then identify root cause and suggested actions to mitigate this risk. Our team is also planning to complete design for manufacturability analysis during the spring quarter. This is done to minimize cost through minimizing parts and manufacturing errors. some of the manufacturing processes that were identified for our prototype. As you can see, we have bent tubing for the exhaust tube, nickel chromium wire that is extruded and then wrapped onto a coil. The reaction vessel is blown glass or molded glass, and the base plate or reaction plate is just a stamped metal part. This is the supply chain design for our project and for our prototypes. As you can see, we have a number of components that are coming out of Milwaukee and Chicago, but we also do have the nickel chromium wire coming out of Texas.
Our team created a demand forecast with a seasonality effect showing spikes around the holidays. Along with that, we did an engineering economic analysis from information obtained from an Energy Star industry scoping report for household countertop appliances. We also created a cash flow diagram showing the costs and profit for the next 3 years. And from that, we were able to calculate a variety of different financial metrics that Noah didn't show yet. And these metrics help to show what would happen if we put the product into market. Next steps, we will be further developing our prototype as well as conducting testing and creating a business plan in the spring. Thank you. Do you have any questions?